Hey guys, how's it going? Welcome back to the second official Carbide office hours. How's everyone doing? Let's see. Stream is good. We got 43 people online. How's my audio sound? I changed the gain on my microphone, so hopefully the levels are a little more appropriate, and hopefully I'm not just blowing out on your end, but it looks alright on my end. Let's see. Okay. Let's see, thanks for doing this. We need a diversion. That is why we're here, guys. Hope you all are staying safe. The weather is actually pretty fantastic right now. It's about 65 degrees and sunny. I actually managed to brave the outdoors today. I went out of my home like more than a block for the first time, and I went food shopping. The grocery stores are recovering. Still some things that are sold out, but otherwise pretty good. Definitely a little surreal. Awesome audio, excellent, glad to hear it. Okay, so I figured this time, instead of just hosting an open Q&A that would go all over the place, that we would do something a little more focused on a single task, and maybe a single just kind of thing you can do in Carbide Create, just so we can narrow down everything we're doing. So today I want to show you guys how I made this quarantine sign. A lot of you will know that I kind of have this thing against like hanging word art signs because I think it's a little cliched, but in this instance I think other than gather or some other cliched phrase, quarantine would be a fantastic sign to have in your home. So I'm going to show you guys how I made this in Carbide Create, and then we're also going to do a variation in Fusion 360, where I can show you some of the obsessive toolpathing tricks that I'll go through in Fusion to get the best possible results. So without further ado, let us start in Carbide Create. Trying the advanced new vcarve after the depth you set, you cannot edit it after it locks the field. We'll take a look at that a little later if you remind me. Okay, so when I first open up Carbide Create, I'm going to make a small sign just because I'm trying to conserve lumber at home, and I really don't want to go out to Home Depot and buy another plank of pine or maple. So I'm going to say my sign's going to be 10 inches wide roughly and 2 inches tall. This will just set the canvas so that I can sort of figure out where to lay things out. My stock thickness, in this case, I'm going to be using a smaller end mill to cut finer details, so we'll say 1/4 inch nominally. I like to zero off the wasteboard, but that is entirely up to you guys how you want to do it. I like the wasteboard because that means that once you set your zero, the end mill is never going to plunge any lower than that, so you can guarantee you're not going to cut into your wasteboard and leave grooves. And if you leave a little extra margin, you can also guarantee that you don't cut into double-sided tape, which will gum up your cutter, which can be a little annoying to clean up. You usually use like a little goof off or some kind of isopropyl alcohol, just something to help pull the adhesive off your cutter. And sometimes that'll also like stick sawdust to the outside edges of whatever you're cutting, so you have to clean that up. So either use a down-cutting end mill to keep all those the adhesive pressed down, or just don't cut all the way through your stock and leave an onion skin. So I'm going to set my stock thickness and zero at the bottom. Toolpath 0, lower left, that's fine. Material, doesn't really matter. I'm going to say hardwood. Retract height for the Shapeoko, I like to go pretty low just because I hate seeing the end mill go up and down a ton. So I'm going to do 0.05 inches. If you've got clamps that could potentially be in the way, make sure that your retract height is above the height of your clamps. Alright, so I'm going to delete some unneeded text, and let's say I'm going to use this text object as the basis for my quarantine sign. So if you're making signs like this, a lot of people like to make sure that all the letters touch, and so if I type quarantine and I apply it, none of these letters are touching. You really want a font that is sort of like cursive or handwriting, where the letters will link up. And some fonts will do that, some fonts won't. I usually get all my fonts from Google Fonts. And it's just a good resource to just reference, hey, like what are some fonts I can use? So I can look for fonts that are more like handwriting, and just find something that fits the mood that I'm going for. Here, Arial really doesn't cut it, and I downloaded a font called Satisfy a little while back, and I like that a lot. Now the thing with these fonts is none of them are ever perfect. Like here, the Q doesn't link up with everything else. That's why for a lot of these signs, you see that people will stick them either on a wall and the letter will be separate, or like they'll have some kind of backing. So if you take apart a palette, you get some rustic looking wood, laminate them together into a board, then you can put your letters on that board and you can have a fancy looking sign that you can move in one piece. Or you can sort of cheat it. So here, what I might choose to do is maybe open up a spline tool and then start just drawing in just some fake cursive to link up these letters. And you can obviously put a little more care into this than me, but like that's quite often how people sort of cheat this. So I can also, let's see, go in here and mess with the individual nodes and sort of get the curves just right. But a lot of like the artistic things that you can do, it's usually just done so it's good enough. Like these curves aren't going to line up absolutely perfectly, and that's okay. But it's just the nature of working with fonts that you have no control over. You could also actually write this out in your handwriting, scan it in, trace that out. So this is one way to do it. For what I did though, I realized that if I did a lowercase q, everything would link up so that I wouldn't need to cheat it. And then I'm also going to bump up my font size here just to take up a little more room. So let's try 1.5 inches. Better. Let's go 2. And so now I've got a vector that all the letters are touching. If I were to do a 2D contour around everything, it'd be fine. But when you're trying to cut out letters like this, it's always better to cut out the inside pieces first before you cut everything out, so it doesn't start like the stock is as strong as possible, and you're not like you have this all cut out, and then when you go to mill the A or the E, the whole thing starts shifting around. And in order to do that, because you can't pick different parts of of font or text, you can create an offset vector. So if you create an offset vector of, let's just say like just a tiny amount, like 0.02 inches outside the text, and apply that, you're going to have a vector that links up everything automatically, and you can select the original font and just pull that out, and then, or just delete it, and then you can select some overlapping bits that aren't needed as well, and now you have a clean vector that you can cut around and also within. I made a mistake here, I deleted that, I shouldn't have. I want to get rid of that piece. And so now when I go into the toolpathing screen, I can pick the inside of the A's, I can pick the inside of the E, the Q, and I can apply a contour toolpath inside that. Now this is a relatively small, fine detailed feature. You can see that an 1/8 inch end mill doesn't fit inside the E. So I'm going to pick a 1/16 inch end mill. I'm going to go Shapeoko, Hardwood, end mill, and the 112. Select that and hit OK. I'm going to call this the inner cutout. I want to capitalize that C just because. And so now we've gotten the inside of the font. Now there's a couple other issues here. The little dot on the I is floating, which means it's going to be cut out separately. And if you really don't want that to happen, if you want to keep things together, again, it's all about cheating things. So I'm going to go into my design and I'm going to pull this little I and just have it overlap the T. And then I'll unselect that. And you could just 2D contour around both of these two contours separately. I'm going to choose to combine them just so that they'll never separate. So you pick one, you pick the other, you go to the Boolean operation, you do a union, and now these are connected for life. Go back into my toolpath, select the large contour, outside, still the 1/8 inch end mill, and we want to make sure that we're cutting all the way to the bottom, so I'll use stock bottom. And I need to fix that in the first toolpath as well. This will be the outer cutout. And then I need to fix the inside one, so use stock bottom, check. And in about 15 minutes, maybe a little less depending on if you want to crank up your feed rates, you will have a sign that looks like this. Perfectly adequate. When I cut out my sign, I used double-sided tape underneath it, so I just put a large 1-inch wide strip underneath everything. When I cut through the wood, I pulled up some of the adhesive, I gummed it up, and I had to spend a little bit of time sanding away the sawdust that got mixed with the adhesive and smeared across the outer edges of the wood. If you're using like a larger cutter, not as big a deal. Down cutting end mill, way better. But you could also opt to use tabs to hold this in and just skip the adhesive work holding altogether. So if I go in and I edit this, I can also apply some tabs here. And then let me get back in this view, edit tabs. I'm going to throw some tabs on areas that are easy to sand. So if you put a tab in between like the Q and the U, it's not great because then you got to get in there with a file and clean it out. So tabs near the outside of features are always the best. So I'm going to put one like at the tip of the Q, outside edges of the Q, tip of the T, potentially one at the dot of the I. So longer features are more fragile, and so those are more likely to vibrate or chip or break. So like at the end of the little E, I'll put one there, maybe the N, bottom of the A. So you go through as you see fit just to apply some tabs and make sure that everything's going to be secure as you cut it out. Tab width, I might do, let's say, 0.2 inches. Tab height, maybe 0.05 inches. This is all going to vary depending on what kind of cutter you're using, because that'll change how violent the cutting action is. So a small end mill, 1/16 inch, it's really not putting a lot of force back into your stock. So you can do something like that, hit OK, show the simulation, and then you can see that there are tabs left where you need it. I'll probably go back in and refine this a little bit more if I'm actually going to like make this as a production sign, and I want maximum reliability, but this is a good place to start. So if you guys have any questions about that, let me know. But I'm going to move on and do basically the same thing in Fusion, just show you how it's done. The toolpathing strategies are basically the same. It's just that you can do some different tricks to reduce the cutting forces or do a finishing pass and things like that. Alright, let's see. Things are looking good in the chat. We are at 119 people. Very nice. Cool. So Fusion 360, you all know this is my one true love, and in here, when you start sketching things out, you're going to want to make a extruded body from your text. And so when you make a sketch, you can create text with the text tool, and then you'll have to try and find the font that you put in. One thing to note is that custom font that you bring in yourself in Carbide Create, if it doesn't show up when you scroll down and you look for text, it's probably at the top. So the fonts up here are the ones that I've imported myself into Carbide Create. If you go into the About, Open Data Directory, and the Fonts folder, you can paste in custom fonts and they'll just be right at the top of your dropdown. So if you got to bring in a font, if you can't find it in that list, try dropping it in the fonts folder and you'll be able to fast track it when you're trying to pick that font. Alright, anyway, back in Fusion, I've got the font I want. Is there a way to 3D contour the top surface of the letters using Carbide Create Pro to be more rounded? There is, although it's not going to be maybe exactly what you want, but I'll show you how to do that first real quick before I get too far into Fusion. So I'm going to say example, let's just get rid of, let's just start from scratch. New, discard. All right, so if I make some text, and then I'm going to make it a little bigger so it's easier to see. So if I have some text and I go into Carbide Create Pro, what I can do is select the text, create a component from it, and extrude it upwards. And if you want to fillet it, you can do a round option on that. And then I'm going to set a height limit of maybe 0.03. I'm just sort of winging this. We'll see how it goes. I'm going to call this text extrude. And then I'm also going to give it a base height. Because if you apply this now, what you're going to see is that it's literally just the filleted part and a little bit above it. But if you add a base height to it, that's sort of just a, hey, you're going to start with at least a 1/4 inch of thickness, apply that, and then now you have a 1/4 inch and then about a 32nd of an inch of radiused edge on the text. So you can do that as a round or as an angle. That's going to make it look more like a chamfer. And then you can just run a roughing toolpath and a finishing toolpath. You'll just parallel finish over that. Hope that answers your question. Cool. All right, so I'm gonna make some text in Fusion let's do something different. And let's pick another font. All right, so this font should work out, although the letters don't connect. So I'm going to cheat it a little bit after I boost the height here. All right, so if I want to machine this out as a sign, I'm probably going to extrude this out to a height of about 0.375. Hit OK. And then to connect these letters, I'm going to do the same thing I did before. I'm just going to cheat it. I'm going to draw some splines to connect the text. So I'm going to create a sketch on my bottom plane and just pull out my spline tool. And we're going to try and connect the C to the A in just a really sloppy fashion, because this is a live stream and I'm not actually going to be caring too much about this. We'll fix that later. All right, so let's see. Just tweak that a little bit. You can play with these handles to change the curvature of your spline. Yeah, this is pretty janky, but this is just an example. If you do this in other programs like Illustrator or Inkscape, you can get much better results. You'll have a little finer control. For the time being, this is good enough. So we'll make a spline there. We'll make a spline here just to connect the D to the 3. This is pretty hacky, but it'll work. And then I'll just extrude these out so that they will join the main body. So I'll pick that, I'll pick this. We'll go up to a distance of the top of this. You might have to change a different blending mode so it connects. And I want these to join. That did not work. Okay. Why did that not work? Compute failed. It's a problem combining geometry together. If it asks me to join, cut, insert, try to ensure that bodies have a clear overlap. Okay, well, next thing I would do is just recreate this in Inkscape and bring it in. In the meantime, though, let's just pretend that we'll go back to the quarantine example, or just pick something else. Things don't always work out in the demos. Alright, I need a quick word. Mesh error with the letter A. I'll play around with this a little later. So I know that's continuous, that should work. Finish sketch, and that'll extrude okay. That's what I want to extrude. Inconsistent edge-face relationship. I'm kind of surprised. Fusion is misbehaving a little more than Carbide Create. Alright, new body. This is... let's just nuke this from orbit and start again. Not the face I wanted to do. If this fails, I'm just going to make a square, and we're going to make a toolpath for a square and call it a day. Mesh error with letter Q. I don't know what that mesh error is, or a quick way to fix that. You can feel free to chime in the chats. I will get back to you, but let's do something simpler. Let's extrude one word. Bad font for extrude, overlapping fonts cause issues. Okay. In that case, let's pick a simpler font, and we'll just pretend that this will be a silly word art sign that will be nailed down to some sort of substrate to keep everything in place. Please work. And we'll do a very standard font, but one I pretty much always write in. Hit OK. Finish sketch. Extrude. Extrude that up by 0.25, and everything works fantastically. That does not look like Carbide Create. How come you are not using it? Because we just went through the Carbide Create example. If you scroll back in the timeline, you should be able to see the example in Carbide Create, or just watch this afterwards. I'll make these linked in a playlist on the Carbide 3D channel page. Maybe I'll make these like fully public. I just feel weird spamming these into your timeline when it's not regular content. Alright, so we have some letters, and if you want to make a toolpath for these, you go into your manufacturing workspace, you create a setup. That setup defines the stock volume that Fusion's going to assume that it needs to cut your letters out of. So if you make this really tall, let's say if you pretend that your stock is like an inch tall, you'll have 0.75 inches of stock above your letters, and Fusion's going to start its cut way up here instead of down here. So defining your stock to be as close to accurate as what you're actually machining out will save you a bunch of time. Sometimes if you don't care, like stock offset on the side, totally okay. Stock top offset will kind of affect how long your machining operations take. So keep this as close to what it should be as possible. Let's pretend that I'm starting from 0.3 inch tall stock. So I need to machine away a lot of material, or not, sorry, this is stock top offset. It makes the total stock 0.55 inches tall, so if I want to pretend I have 0.03 inch tall stock, it's going to be 0.05 inches there. Yeah, add all the models, Cool. So let's say this is a representation of the board that we're machining this out of. We're going to want to machine away all the excess material on top so we can focus on cutting out the letters. You would do that with a facing operation, and you'd probably want to select a larger tool just to make things go faster. So I'm going to pick a Carbide 3D 251 Nmil. Roughly 80 inches per minute. I'm okay with that. Let's see. I could definitely extrude out each letter individually, kind of tedious. It'd be easier just to bring in a regular SVG from Inkscape or some other Illustrator program. Let's see, I'll try that exploding text thing afterwards. But normally I just bring in an SVG or a DXF from a vector graphics program and just extrude that out. All right, so to face everything off, I have the face toolpath selected. I've picked my tool. The geometry, it's just going to assume that the stock volume is what it needs to face down. And I can also do multiple step downs in case, like, if you have a really thick piece of stock and you want to come in at a slightly gentler approach and take shallower passes off. I'm going to do 0.025, so it'll take 2 step downs to cut through 0.05 inches. And then my step over, I don't like 100% step over. I think about 80% is pretty safe, so I'll do 0.2 inch step over. Let's see how that looks. So it's going to come through, it's going to face off my stock. In reality, you really would only need to face the area over where you're cutting. So I'm going to go back into my setup, and I'm going to reduce the stock offset from the side, so it just focuses down on a narrower area. Let's see. Question of, is the tool selection good for the Nomad and the Shapeoko? I mean, the tool selection is literally any 1/8 inch or 1/4 inch shank tool. On the Nomad, you can buy third-party collets, and then like, the world is your oyster. Like, ER collets come in basically any size up to about 7 millimeters. So you could use drill bits there. You can use end mills, 3/16 inch, 3 millimeters, 6 millimeter shank. It's pretty much anything. Let's see. What do I use most often? Fixed size, relative size, or model your stock? What are your pros and cons? It depends. Usually I'm just using relative size, and I will really only worry about the top offset to get my stock to the thickness I need. After I knock out the regular 2D version, I'll show you why you might want to care about the side stock and how to define that a little more accurately. And that's more important in 3D machining operations, because Fusion will machine anywhere it thinks there's stock that's not your model. And unless you constrain it to work in a very specific area, it's going to try and machine everything away. So if I were to say, hey, my stock is like massive, it's going to try and machine everything away. But for a 2D operation, we can say, hey, just follow these letters. It's really not that big a deal. No model selected, ignore that warning, yes. So I've faced it. I'm going to do a 2D contour. I'm going to use a 1/16 inch end mill. So this would be a tool change. If you have the bit setter, great. If not, do it manually. Let's see. So the 1/16 inch end mill selected. I'm going to first cut out the insides of the letters that have holes in them. And we're going to say, we're going to do this in, sure, 1 millimeter step downs. Hold on. No, we're not going to do that because this is America. We're going to do 0.04 inch step downs. We're going to make them even, and let's see how that looks. All right, so nice even step downs all the way through. And then we want to basically do the same thing, but on the outside of the letters. So I am going to, instead of just creating a second 2D contour operation, setting its step downs, I'm just going to duplicate this one. Duplicate. And in the duplicate, I'm just going to clear out the contours I selected and just pick the letters. Let's see how we're doing on comments. Constraining toolpaths, we will get to that. Okay, so now that we've got a toolpath that works around all the letters, this would probably be something that would be easiest to machine with an onion skin. So just machine down, leave a little bit of stock at the bottom, so don't cut all the way through. Like you can stop your bottom height. I selected the bottom edge of my contour, so the toolpath's going to go down to there. I can say, hey, stop short like 0.015 inches. And then my toolpaths will generate, and they will come down to right about here. And so you can see that this isn't going to cut all the way through the stock. You can cut a little deeper. You can play around with that onion skin, maybe make it like 0.05 inches, or sorry, 0.005 inches, and then just sand away the back and liberate all your letters. So there's a lot of different ways you can do this. Just given that these letters are all separate, I'd probably go with the onion skin. Why not do tabs? You can. You just have to clean all of them up. And for a font like this, you'd have to put tabs literally on every single letter. So for example, that would look something like you'd have to position them manually, because if you did like at a distance, it would throw tabs wherever it felt like, but some of the letters would not get tabs. Like the S doesn't have a straight line segment, so it never triggers the, hey, there's a minimum straight area of ½ an inch. It's not going to work. You're going to have to go in and say, like, I want a tab here, I want a tab here, preferably 3 points of contact per letter, just to keep everything secure, and then throw some tabs on the curvy parts. So it's just going to be a little tedious. That's why it's nicer to have a font that's just one piece like this. Best way to start learning Fusion 360 for woodworking and CNC: find a simple project where you can focus on just using some basic toolpaths like 2D contours, 2D pockets. Lars Christensen, he works for Autodesk. He has a great set of videos that basically hold your hand through the learning process. Autodesk's own resources are pretty good. Their tutorials are very solid. More advanced toolpaths, you can check out NYC CNC. Why does it seem like so much more work in Fusion than Carbide Create? Because there are just so many more options that you have to get through them. With Carbide Create, like, everything is assumed to be basically 2D unless you're using Pro. So it's just create vector and make a toolpath based on those lines. With Fusion, you have to work with a 3D model. So it's create 2D vector, extrude it out into 3D, and then apply toolpaths after going through all the options. For me, it'll take probably about the same amount of time because I can fly through the tool dialogues a little faster because I know what I'm looking for. But really just use the tool that you're most comfortable with and just ease yourself into new tools. Like, don't worry about like, oh, this is so daunting. Start with something simple, like just make a sign. What am I drinking? I am drinking tea with about a teaspoon of honey just to help the throat because, again, I really hate public speaking. Different tool depending on which machine you had. It really depends on the size of the piece you're making. So for something like my little quarantine sign, like for reference, this is the size compared to my face. It's not big. The features you're cutting out are going to need a tiny end mill to get into. So 16th inch end mill works on both the Nomad and the Shapeoko. If you're to cut out even smaller letters, you might really want the Nomad, especially if you're cutting letters out of brass. I did a brass inlay for my friend, and those letters were like 3/8 of an inch tall, and that really needed the Nomad's high precision spindle. It might be gin and tonic next time. We'll see. Let's see. So, some things I might do to, if I'm being really paranoid about how these letters are coming out, if I'm like really wanting the best possible surface finish, is I will run a second spring pass or a finishing pass around these letters. Because as you're cutting, there are forces that are pushing the cutter away from your letters or pulling it towards it. And in those instances, you might want to leave a little stock to leave around the your parts. So if I say radial stock to leave of 0.05 inches, no axial stock to leave, that's going to push out the toolpath just a little bit from these letters. So I don't know why this is taking so long to calculate. It's probably just text having so many curves. Fusion doesn't like that. So compared to the previous toolpath, it's just a little bit further out. It's hard to flip back and forth between these. If you want to add a spring pass to clean things up, I would just duplicate your toolpath. And then the spring pass is a much later pass, but since you're not plowing through material on all sides of the cutter, you really don't need to do such shallow depths of cut. So I would do maybe like 1/8 of an inch or more. And then you don't want any stock to leave on that. So if you compare these two toolpaths, you're going to have the original and the finishing toolpath. And the finishing will be a lot faster. And the finishing also is just a little bit closer to the inside of the letter. And so that'll just trim everything up nicely and leave you with the best possible surface finish. You don't need to do a spring pass. You can also enable a roughing pass in Fusion 360. And that basically just makes it go around the letter twice, once a little further away, the second time a little closer. So it's almost treating this like a pocketing operation, except you don't need to make a second offset contour that's just outside of the letter. So that would look something like this once it generates. Hello newcomers, hello Chrissy, hello Leanne. Please use words and not emojis. Did you use a 16th inch bit on that 3/8 inch brass? It was 3/8 inch tall letters, and I used a 1/32 inch end mill. Consider the sharp interior corner will be the radius of the cutter. That is correct. So the smaller your end mill, the tighter you can get these corners. So if you do a simulation, this cutter is going to leave stock that looks like this. I'm going to make this transparent. So it's not going to cut a perfect corner. It's going to leave a little something in there. The smaller your end mill, the tighter these corners are going to be. Or you could just come in here with a file. There's going to be a limit to how sharp you can make that turn. Just because like a 1/32 inch end mill, it's really hard to find that in a like 1/4 inch or longer length. And so that's one of the problems. Like I can't just use a 1/16 inch end mill and just straight up machine this out of 3/8 inch stock, because what's going to happen is our cutters sort of have a tapered shoulder. So as you cut through this, if I show if we didn't do the facing operation, if we just did the contour, I'm going to simulate that. I'm going to say at the bottom here, your cutter, that shoulder is going to start rubbing against the material that's on top of the letters. So that's why if you're starting with thicker stock, definitely face it down and take note of how long your cutter is. So that branding iron video, there were 2 faces in my 5-in-1 branding iron that were machined on the Shapeoko. So the Shapeoko is totally capable of machining, where is that? Of machining brass, and I'll try and do a video in the next couple of weeks. So these long ends of that branding iron, I was not able to machine in the Nomad because it's too tall. So I did a really janky setup like this to machine it. So those letters were done on the Shapeoko, and they came out pretty good. Again, it's just a matter of making sure you're going slow enough. And no Carbide 3D attire today. It's a little chilly indoors. I'm acclimating to California, and like 65 degrees. That's long sleeve weather. Is the HTZ and 80mm spindle mount likely to still be in stock towards the end of April? That's a long ways away. Not sure. You'll have to talk with sales about that. Is there a Carbide 3D Discord? No, there is not. Should we have one? Let us know in the comments and in the forums. Let's see. Thank you for doing all this. Thank you for joining us, James. Please post a recorded version. These versions will be available after the stream is over. youtube.com/carbide3d. If you scroll down, we will have a playlist of all the office hours down here. So you can go check that out later. A Carbide Discord. All right, I will bring that up with my boss. We will see. Let's see, are there any other tricks in Fusion that I would do? For something like this, probably not. Okay, I remember there was a question about stock and why you would set that or not, to be very specific and close to what you're modeling. So pretend I didn't do these 2D toolpaths. Let's say I had something more complex. Let me see if I have an easy example out here. Let's pretend we're machining a CPU heatsink. Why don't you? This would be interesting. I haven't made the cam for this yet, I don't think, so setup. If I say I have a block of copper that is exactly this big, and I apply an adaptive clearing toolpath with no constraints whatsoever, I'll show you what it's going to do. Let's do an aluminum, let's say 1/8 inch flat end mill, sure. Don't even care about the settings, I'm just going to run with it and see what it looks like. So this adaptive toolpath is going to try and remove everything that is not the model it cares about. And because it thinks the stock is this big, the toolpath doesn't need to go very far to clear it out. If, however, I say, hey, I'm starting with a piece of stock that is like 1 inch larger on each side, and then I say, hey, just do an adaptive clear. Get rid of everything that's not the model. It's going to go through and it's going to hog out a ridiculous amount of material. So in these instances where you're, let's say you have a piece of material in a vise and only the top 80% is exposed and you're going to machine away everything, like you might do on an actual VMC, you would want to clear away everything. But if you have just a large piece of flat stock taped down to your wasteboard, you really only want the toolpath to focus on the part you're cutting out, and usually it's a 2D operation, so you wouldn't need to worry about this. Now, if your stock is this big, actually, the reason you would want to make sure you have a little extra stock modeled in here is that if you recall the previous toolpath, if you said your stock is this big, but it's really a little further out, it's going to start the adaptive toolpath like in the middle of the stock, and you're just going to break a cutter. So always make sure that either your stock is a little bigger, like just a fraction of a millimeter bigger than it actually is, and you set your zero correctly, or it's okay to have like a little more stock. You just need to constrain where the toolpath works. So with any 3D toolpath, you can go into the geometry tab and set your machining boundary to be a silhouette of your model. So basically, whatever shape this is, work within this outline. You can add a little extra margin, so I want my tool to go outside of this, and it'll do its magic within basically an invisible bubble around this part. Sometimes that's faster, sometimes that's slower. In cases like this, you can see it's doing a lot of little adaptive arcs. This is a case where it would just be a lot quicker to plow through the outer profile with a 2D contour and then work from the outside in. And if you were to do that, you would end up with, let me just throw a 2D contour on real quick. 1/8 inch end mill, sure. You would end up with a piece of stock that looks like this. Ignoring the stuff on the outside, it would just be an X-shaped blob of material in the middle. and then future toolpaths could work from that. So, and that's one case where you might want to model the stock. Because then you can say machine away everything just over the model. Let's see. Is there a way to have Fusion automatically mill out areas where the bits that have wider shoulders so it can reach further down than it normally would? So if you're machining a really tall object, I'm just going to make a new design. If you're machining out something that looks like 0.5 inches, if you're making something like this and you're milling it out with a 16th inch tool, it's not going to work. You can machine further out from the contour, but you're never going to be able to pull the end mill right up to that edge. So if I pick my 16th inch tool, let's see, let's simulate that. Let's see the tool down here. That is not half an inch. Please hold. I said 0.5 inches. All right, so there's just no way for that tool to go all the way up here with that shoulder being there. What you can do is you can cut a 1/4 inch down, and then for the remaining cuts, you cut a little further out. So like if you really wanted to do that and you didn't want to stick in just a straight end mill, you can, so I'm going to make a version of this toolpath that stops 0.25 inches from the top. Minus 0.25. That was not correct. Minus 0.25. I'll have a toolpath that stops there, and then you just make another toolpath that starts, that ends further down. Let's say all the way at the model bottom, and stay off the walls using stock to leave by, I would say, 0.05. But at that point, you're really losing the benefit of using an end mill like that. So when it comes down here, the shoulder would be off the wall. You can dial that in a little bit. However, if you're going to do something with a chamfered top, then you could use a 16th inch end mill and carve like a really tall pyramid, because that there would be no collision with the shoulder. This would just get out of the way before the shoulder could even come in contact with this. This would even clear the collet of your router, or probably even the router itself. So it really depends on the kind of geometry you're doing, and just be aware of these kinds of collisions when you're designing. Do I recommend double-sided tape as work holding for making signs? If you're using a down-cutting end mill, definitely. If you're using an up-cutting end mill, I'd just be aware that you're going to pull up that adhesive from the cut edges of that double-sided tape. But personally, I use double-sided tape like 80% of the time, just because I'm lazy. Have I ever used generative features for making something? When, I think around December 2019, Autodesk made generative design free for a month. I tried making some stuff, didn't come out really usable, so I never ended up following through with that. Can I send you a file to machine? The next time we make an announcement for a Carbide office hours, you can suggest something or a question or submit a file, and we will see if we can get to that. No promises, though. Also be able to, depending on the size of what you need, also materials. Yeah, you gotta scale your ambitions to the size of your machine. So, let's see. Are there any other Fusion questions while I'm here? Let's see. Any advice on using V-bits on two-tone HDPE? really, for the most part, you can treat HDPE like wood, like you can plow through it pretty quick, but there are some cutters that are going to work better. I don't know how well our 301 and 302 are going to work in HDPE. Plastics really like having a sharp knife cutting edge on your end mills, and the 301, 302, and the Amana RC 1148, I think, they look and act more like card scrapers than anything else. The cutting edge is perpendicular to the rotation of the tool. How do you handle thread milling? Okay, let's go down that rabbit hole. Thread milling, first of all, you need to program in your, not this folder, not that folder. If I can find something. GoPro modifications, maybe? So with thread milling, you have a tool that might look like a double angle cutter, but it's actually got a flat at the tip, so it follows the standard NC profile. I'll show you how I set up my thread mills in Fusion in a moment. Do subsequent toolpaths know what previous toolpaths already removed? 2D toolpaths do not. 2D toolpaths will just say, hey, I'm going to follow this contour all the way down, and if you do a subsequent toolpath, it's going to start from the top and work its way down. 3D toolpaths, if you do an adaptive clear, and if you do another adaptive clear after that, you can say, use rest machining from previous operations, and then it'll look at what's been machined away, and it'll ignore those areas. You'd normally do rest machining, subsequent rest machining with smaller tools to get what a previous tool would have missed. Okay, back to thread milling. My thread mill is specified in Fusion 360 as, unsurprisingly, a thread mill. I have a single point thread mill, so just one profile of a 60-degree thread at the tip. Pitch, whatever, doesn't really matter. What's important is the thread profile angle and the diameter, number of teeth maybe. You can modify the shaft if you have a certain profile, if you have a really skinny neck and it goes to a wide shank and there's a taper or something, but here it really doesn't matter. And then in the thread milling operation, it is a 2D operation. You go under thread and you pick a cylindrical face. So my thread milling operation looks like this. Pick my thread mill. Here it's tool number 3. Pick your face, and then pick your thread pitch. So that's how far away each of these lines is. A number of step overs. I chose to do this in 3 step overs just to keep it nice and simple. So it's moving out. Let's see, about 0.01 inches at a time. And then no stock to leave. There's a pitch diameter offset. So this controls how far out that cutter will go. Because normally, if you measure a 1/4 inch bolt, it's not gonna be 0.25 inches in diameter. It's gonna be like 0.248 or something. And so there's a little difference between externally and internally threaded parts, and that pitch diameter offset helps you figure that out. John Saunders, NYC CNC, has a great calculator to help you do that. So go check out his Excel spreadsheet if you really need to figure things out like this. Oh, hey, bro, stamps, 3D type stamps, good stuff. The Nomad is only 3-axis, but there's got to be a way of getting what I'm looking for. I mean, you can do complex contoured shapes. You just won't be able to do any undercuts. And if you're imprinting in glass anyway, you probably wouldn't need undercuts. Hit me up after this and we can talk through that. Is there a way to save out your stock and import it to the next operation? For the most part, that's just based on, if you use rest machining, you can do that. Here, if you were to, let's say, do a 2D contour and just cut through your stock and pull it away, and you want it to just do an adaptive toolpath that was more efficient, focused on this part itself, you'd probably want to do this with like using a separate setup, using like predefined stock body. So let's say I did this. Let me just get rid of some of these things that I don't care about. Whatever, we'll just extrude them out. I'm going to do this as a new body. And I'm going to say this will be 6 millimeters tall. Nope. Let's say, oh, did I say this was 1/4 inch? 6.35. Of course I did. 1/4 inch is the best. So if I were to go into my manufacturing workspace, make a new setup, and say, hey, my stock is now exactly this size. And my model is this piece. I'm going to hide this. Actually, I won't hide it. I'll just minimize it. So it's going to say, hey, my stock, this is all I have to work with. This is what I'm trying to machine out. When you apply a 3D adaptive toolpath to it, it's going to really efficiently go around the areas that it needs to. So instead of before, how I think I deleted that, it was doing like, I'm just going to recalculate everything. Instead of doing little adaptive arcs around these ears, oh wait, it's not constrained anymore. If I do silhouette, tool, center on boundary, let's say, and then stock a little larger. I know I'm being a little disjointed about this, but if you're to do an adaptive toolpath in a larger just ocean of stock, it would look something like this. Will calculate eventually, I think. No, it's not. I need to allow it to go outside the stock. Tool, outside. That should work. Maybe. Once this calculates, you can see the difference. So instead of doing little adaptive arcs around these ears, which is really time consuming and stupid, if you cut out the whole piece first and then have a setup that is just focused on what's left, the adaptive toolpath is going to work its way from the outside in, and that's just going to end up being a ton quicker than the other adaptive toolpath. It's also going to be way faster to calculate. So that is one case where modeling your stock would actually pay off. So this, even though they're machining away basically the same thing, this one takes 13 minutes and this one takes 5 minutes. So it really depends on the kind of model that you're using, whether or not you want to use rest machining or whether or not you want to very specifically and accurately model your stock. Let's see, from simulate, right click, save as stock. Yes. So if you say like, hey, this is everything I machined away, and you simulate that, there should be a way to take whatever stock that you see and save that out. Someone can point that out in the comments exactly where that function is. I haven't used it in a while. I remember John Saunders showing it. So there is, it's somewhere. I don't think they took it out in an update. All right, let's see. Is there a speeds and feeds chart for the Nomad cutters? I was only able to find one cutter. So there used to be a speeds and feeds chart, but that is now obsolete. It used to look like this, but these were all like with an 1/8 inch cutter, and it was sort of like one size fits all. The new version of Carbide Create, if you go into, well actually you don't even need to go into the toolpath menu, you can go to Edit, Show Tool Database, and then you can pick a machine, and any material. And then each of the cutters that are in this category, you can see what our recommended starting speeds and feeds would be for any 2D operation. They also include 3D cutting parameters, which are pretty conservative, so you can definitely crank the 3D cutting parameters up a little bit, as long as you've done a roughing operation first. And if you want to just look at all of these in a less tedious fashion, what you could do is you could duplicate a library. I'm going to say an acrylic library for the Nomad. This is going to be my library. And any custom library can be accessible as an XML file. So I'll just say OK. I'm going to go into the data directory again. And instead of going into the fonts folder, I'll go into the tools folder. And there is an acrylic tool database for the Nomad that you can go through, edit, and modify yourself. Oh my gosh, Microsoft. No. No. Okay. You can go through, you can add more tools, you can remove tools, you can tweak the speeds and feeds. And so this would give you complete control to rapidly and fully create any tool you want and bring that back into Carbide Create. You can also just save some of these columns as a reference. You can hide the columns you don't care about, and just use that as a reference. And at some point, we do want to have an online lookup version of this. So I will keep harassing my boss to do that. But in the meantime, if you want to just look at all of the data all at once, you can open it up as a CSV file. There are no machine specs for the Nomad or the Shapeoko. I'm not sure how many people would actually care. So you can make machine profiles, and you can also plug in what their accelerations are. I've made one just to play around with it. So you can say hey, I've got this resolution on my x-axis. These are my rapid feed rates, so that when you generate setups, the machining time estimates will be accurate. Because a lot of the times when you're doing rapid moves, like the moves in yellow, it'll assume that the machine is just moving at light speed. So by applying machines to, let's see, if you select a machine, if you say I'm using the Shapeoko, it might affect some of the time estimates shown. We need to look more into this before we release something officially. Yes, I can share these offline. Send me a DM on Instagram or something, or shoot me an email, and I'll try and send these over to you. Carbide 3D feed recommendations for feeds and speeds have any impact on tooling life? Hey Richard, how's it going? Hope you're doing all right in quarantine. So the speeds and feeds that we have are really just middle of the road speeds and feeds that are general purpose. So and since I came up with these, I can tell you that my motivation was to go for a slightly larger chip load. So you go a little shallower, but you go faster, so that you're taking a larger bite out of the material. And in plastics and metals, that's a lot more helpful because that helps sequester heat in the chip that you're making. If you cut deeper and slower, there's a different trade-off, but instead of only wearing away the very tip of the end mill, you're spreading out that cutting across more of the flutes. It's sort of a trade-off depending on what you're cutting and how you're cutting and what your priorities are. Rubbing is not allowed. Yes, you want to make sure that as the end mill is slicing through the material, it's actually shaving off pieces and not just creating dust, because that just means friction, that means heat, and that will decrease your tool life. My chair is kind of okay, comfortable. It's a gaming chair from Staples. I do not recommend it. The foam padding pretty much anywhere on this chair is all right, but in the seat, they use a cheaper polyurethane, and it doesn't really hold its cushioning as well. So if you're sitting on it for a while, it's going to get flat really quick. So spend more than $100 on a chair. This is only in my office because it's my secondary chair. In my bedroom where I work and edit most of the time, I have a better chair. I believe the tool library and other files that you upload will be saved when you upgrade to different versions of Carbide Create. Although it's always a good idea just to maybe copy and paste this into a Dropbox folder somewhere. Crystal, if you have a Carbide mug coming, just send it my way. I find on the HTZ I can use the same chip load as you mentioned in your video for single flutes, but I can cut significantly deeper, up to 7mm with a 1/4" cutter. So yeah, you can definitely push faster than the speeds and feeds I recommend, but a lot of it just comes down to how adventurous are you feeling. So I have used a 1/4" cutter on a HTZ Shapeoko running a router, not a VFD spindle, up to about 0.3 inches deep. So that's about 7-ish millimeters. You can be that aggressive, but I've found that when you're taking such large chips, there's a lot of heating that happens as you're ripping the aluminum apart. And so that would work a lot better with a mist cooling system or air blast. But for really short durations, if you've got your stock held really solidly in a vise or clamped down, you can pull it off. Is there a good video showing the benefits of Carbide Create Pro? We just released a video yesterday, just giving you a quick overview of Carbide Create Pro. I can run you through the gist of that real quick though. So I'm going to make a new project, discard everything. So this is basically everything that happens in the video, just at a much slower pace. So if you want to save your time, because I know we are going a little over time, you can just watch that video. But basic gist is that Carbide Create Pro works by taking the geometry, the drawing tools that you know and love, and adds the ability to extrude them with different edge blending styles. So let's see, if I were to create some squares and I were to select one of them, go to the shape command. From here, what I can do is I can apply either just a straight wall, an angled wall, so let's say 30 degrees, and I will limit the height to 0.25 inches. And let's apply that, let's see what it looks like. That's going to make a shape that looks like this. I'll say done, hide 3D. If I create a shape that's flat, that is 0.5 inches tall, and I apply it, it's going to make something that looks like this. And so with these tools, you can very quickly build up 3D shapes. And we have another one that's rounded. Let's say height limit of 0.3. You can make all sorts of shapes, add them together, combine them, remove them. And so some of the things you can do are, let me give you another example. I have some of these saved. You can make a carving that looks like this. This is a rectangle built on top of another rectangle, but with a subtracted chamfered edge. And then in the resulting pocket, I added in a grayscale height map. A height map that looks like this. So this is just white represents higher areas, dark represents lower areas. You add these on top of the features you're creating and superimpose them, and then you can create different things to carve. So I can run you through how I designed that. So you need to also delete your previous components. So I'm going to delete that, and delete that one. Starting from scratch, we're going to make a rectangle. And in that rectangle, I'm going to extrude this up about, it really doesn't matter how tall it is. Extrude it up by 1/2 inch. Cool, that looks correct. And then I'm going to select that same contour. I'm going to do an angled extrusion, and it's going to be 45 degrees. I'm going to limit the depth of this to 0.25 inches. I'm going to call this the Great Depression. And this is going to be a subtractive thing that goes on top of what we did. Apply that. So now we have a dished area that looks like this. You can make it rounded, you can make it fancy, you can use a rounded rectangle instead, whatever you want, doesn't matter. And then within this, I'll bring in the grayscale height map of that horse. Bring that in. I'm going to hide the 3D. It's not exactly centered where I want it, but the size is approximately correct. I will do 0.65 scaling just to make it a little smaller, make sure the mane and the hooves don't hit the beveled edges. Let me go back, edit this. I'm going to center this. Apply that, call it a day. And actually, I forgot to change the height, the scaling of this, so this is probably going to be super tall. But you could make this so it doesn't stick out nearly as far. And what you can do with something like this is, like, if you have a cutting board or a tabletop, you can just set your 0 at the top and just machine an inlaid feature like this. Comparison between stock Z-axis, Z+, HDZ, specific for drilling with a twist drill. Drilling, uncertain about that, because a lot of people say a router is too high RPM to drill safely. I'll do a little experimentation. I'll play around with that and find out. Jennifer, you strike a hard bargain. I will consider it. Is there any Linux support for Carbide Create or other tools? At this time, there is not. It is strictly PC or Mac. Let's see. Can you control the depth in grayscale? So that, it really just depends on, let me get out of 3D view, let me delete this. When you're creating components, you can specify like the height of your chamfer or your roundover, and then a base height on top of that. When you're doing the grayscale images, let's see. When you first bring them in, you can adjust the height scaling there. So what I should have done is I should say I want this horse to be like plus or minus 0.125 inches. The scale should be a lot smaller here. Let's take a look at that. Good enough. So this should be much shallower, and I could just move it and center it. But you can adjust the height scaling of images that you bring in. And then for machining this, I can show off the new roughing and finishing toolpaths. Basically, they work by selecting a contour, and then it'll just work within that. And the one thing to be aware of is that when you're modeling things, you got to make sure that the height of the resulting 3D object is not greater than the height of your stock, or that they're fairly matched. So I don't actually know what the height of all my extruded pieces are, but if I do a 3D roughing toolpath on the rectangle, it's just going to plow through everything that's in there. I'm going to select a 1/8 inch end mill for hardwood or something. Select that. It'll calculate whatever it needs to calculate, and hopefully I got that height right. So it looks like my model is taller than everything I created. Let's see, that looks like it should be 1/2 inch, so I'm going to reset my stock to half an inch. Ideally, you just keep track of these things in your head and make sure that they match up. Recalculate that 3D toolpath. And so now you can see that we have a roughing toolpath that's going to create that beveled interior profile. And then once you have that, you can select your contour and say, hey, make a finishing toolpath that works within the rectangle. Ideally, ball end mill, but you could maybe get away with a flat end mill sometimes. So I'm going to say 1/16 inch ball end mill, select, OK. And that's going to make a raster style toolpath, so I'll disable the roughing toolpath so you can see what this looks like. And that's going to just have the toolpath go back and forth in lines to create the pocket. So that's basically Carbide Create Pro in a nutshell. There's a lot you can do with it just because you're adding shapes in an infinite number of combinations. Another thing you can do is make a topographic height map. So instead of importing something fixed and whatever aspect ratio you want, I made a square crop of a terrain map. Well, it looks like that. Let's say height scaling 0.5. Sure. Well, I had the previous features there, but you can sort of see how you would build up a height map. You would do this ideally with a little extra stock built up underneath it, so you're not cutting through to the bottom of your wasteboard. But yeah, weird, intricate carvings, decorative flourishes, topographic carvings. The world's your oyster. The ball end mill will not give you a sharp corner, but depending on the diameter of that cutter, it'll get pretty close. If you want a sharp corner, you could use a flat end mill, but then you need to machine it in across in one direction, and then also the other direction, because a feature like this has a sharp corner on the X, positive and negative X side, and the positive and negative Y side. Fusion question. When a bit setter is available, will multiple tool workflow trigger the tool change and bit setter length measurements? So if you generate G-code, anytime there's an M6 command, you will trigger a bit setter probe. So if you look at any G-code, if you see M6 command, that's going to tell Carbide Motion, hey, check this tool on the bit setter. If the tool number is the same in a subsequent operation, it's not going to do that change. So in Fusion 360, if you have different tools, you got to make sure that the different tools are numbered differently. So in your tool library, you go in there, you make sure each tool, edit tool, has a different number assigned. Otherwise, if you have all your tools labeled tool 1, Carbide Motion's not going to know, hey, this 1/4 inch cutter is not the same tool 1 as an 1/8 inch cutter. Carbide Create keeps track of that automatically. That's why we number our tools 102, 112, whatever. So that is what will trigger the tool probe command. Any issues or gotchas you learned when doing inlays? If so, what are they? So right now, when you do a V-carve like this, we don't have a tool for you to automatically calculate the inverse of this so that you can do a matching inlay. This is really just for pocketing. So if you want to carve out large pieces of text, if you want to paint them, this is a great tool. I am pushing for us to just do a couple extra calculations to get that inlay feature. But for the time being, this is really just a pocketing tool and not a true inlay tool where you can create a matching carving that can be reversed and flipped into this to fill it up and bring it back to a level surface. All right, we are now 20 minutes over time. So if there are any final questions, I'm happy to answer them. But students, you are free to go. We will try and do this again next week, and I will find another question. I'll have something posted up in the forums probably by Monday or Tuesday. So if you have any specific questions you want answered, feel free to just drop them in the forums, and I'll try and address them. And then, let's see. Yeah, thanks for joining in, guys. Hope you all have a great, safe weekend, and we'll see you again soon. All right, take care, folks.